Ever tried to take a selfie and just couldn't get it right? Maybe the lighting was off, your arm was at a weird angle, or your camera focused on the background instead of your face. Yeah, selfies aren't always easy to take. Now try doing it on Mars, where there's no easy way to check your shot and a whole lot more to worry about than bad lighting. That's exactly what NASA's Curiosity rover faced after landing on the Red Planet in 2012. In 2021, Curiosity snapped one of its most impressive selfies yet, posing in front of a towering rock formation. While it's taken plenty of selfies over the years, this one stood out. Not just because of the striking landscape, but because it marked a key moment in the rover's mission. Curiosity was preparing to drill into the rock, searching for clues about Mars' ancient climate and the possibility of past water. Capturing that moment wasn't easy, but it provided us a glimpse into another world. However, Curiosity isn't just taking pictures. It's a full-scale science lab on wheels, built to uncover Mars' secrets. Why do we keep sending rovers like Curiosity to Mars? What are we hoping to learn? And what challenges does a mission like this face? Let's find out. By the 19th century, astronomers had used telescopes to map surface features on Mars that some people mistook for artificial canals. Later telescopes revealed polar ice caps and dried riverbeds, fueling speculation about water and even life on Mars. However, in 1965, Mariner 4, the first spacecraft to visit Mars, sent back images of a cold, barren world covered in impact craters, more like the moon than Earth. These images shattered hopes that Mars had lush vegetation or widespread surface water, forcing scientists to rethink their ideas about the planet's history. Since then, every rover, lander, and orbiter sent to Mars has worked toward answering three central questions. What was Mars like in the past? What is Mars currently like? And could Mars support human life in the future? If we want to understand Mars' history and future, we have to follow the clues, and few are more important than water. On Earth, water means life, and on Mars, we see clear signs that water once flowed across the surface, winding river channels, dried up lake beds, even minerals that only form in water. But Mars no longer has liquid water on its surface. So how long did Mars stay wet? And was it ever truly habitable? That's exactly what Curiosity was sent to investigate. But how do we even get these high-tech rovers to another planet? Let's take a look at what it takes to reach Mars. Each rover is designed with a specific goal in mind, because what we send determines what we can learn. Curiosity was designed to do something no other Mars rover had done before: drill into rocks and analyze their chemical composition. But to carry all that advanced equipment, it had to be much larger than previous rovers, about the size of a car, weighing nearly a ton. That meant getting Curiosity to Mars was no small feat. The journey to Mars started on the launch pad, where Curiosity was strapped inside a spacecraft and launched atop a powerful rocket. To break free of Earth's gravity, it had to reach speeds of over 25,000 miles per hour. But launching a mission isn't just about raw power. It's about timing. A launch window is the limited period of time when a spacecraft can be launched to reach its destination most efficiently. Take a moment to examine this graph showing the launch of missions going to Mars. What do you notice? Pause the video and see if you can find a pattern. Earth and Mars are constantly moving, so missions have to launch during a specific window that only opens once every 26 months. This is the time period when the spacecraft's journey will be the shortest between the two planets. Even then, the spacecraft doesn't travel in a straight line. It follows a carefully planned trajectory, covering over 300 million miles in about 7 months. But launching the rover is only the first step. It also has to stick the landing. Curiosity was too heavy for the airbag landings used by previous rovers, so NASA developed a new landing system, the Sky Crane. Later rovers, like Perseverance, also used this system. As the rover approaches Mars at over 12,000 miles per hour, a heat shield absorbs the intense entry heat, followed by a parachute to slow it down further. In the final seconds, retro rockets fire to reduce speed, and the Sky Crane gently lowers the rover on cables before detaching and crashing a safe distance away. But here's the real challenge. Because Mars is so far away, mission control can't steer or make last-second adjustments. By the time a signal reaches Earth, the rover is already on the ground, one way or another. Every step of the landing sequence has to be pre-programmed with no room for mistakes. This entire process is so intense that engineers call it the 7 minutes of terror, a stretch of time where everything has to go perfectly or the mission fails. Fortunately, Curiosity survived the landing. It landed in Gale Crater, a massive basin that once held a lake. Now it had to survive being on Mars. Now that it landed, Curiosity had to withstand the harsh Martian environment. First, there's the temperature. Mars is freezing. Nighttime temperatures can drop to negative 100 degrees Fahrenheit, cold enough to damage delicate instruments. To survive, Curiosity relies on a nuclear battery that converts heat from radioactive decay into electricity. Unlike solar-powered rovers, Curiosity doesn't have to worry about dust blocking its energy source. A lesson learned after dust buildup ended the missions of previous rovers like Spirit and Opportunity. However, it can still cause problems. Dust can build up on cameras and sensors, making it harder to collect clear data. It can also get into joints and moving parts, wearing them down over time. Then there's the terrain. Mars is covered in jagged rocks, steep slopes, and soft sand that can trap a rover's wheels. Curiosity's wheels were built to handle rough terrain, but they've still taken damage over the years. Engineers had to adjust Curiosity's driving routes to avoid sharp rocks that were slowly wearing down its treads. Between freezing temperatures, relentless dust, and rough terrain, every rover on Mars is in a race against time. Yet, Curiosity has lasted far beyond its original 2-year mission, continuing to explore Gale Crater over a decade later. Curiosity has been collecting data for over 10 years. By analyzing the rocks and soil, Curiosity found evidence of ancient water that could have supported life. In fact, Curiosity confirmed that Mars once had the right conditions for microbial life to exist. Beyond looking at the past, Curiosity helps us answer questions about what Mars is like today. Currently, Mars is a frozen desert where stable liquid water cannot persist on the surface. However, scientists believe some water might still be locked underground. But it's not just about water. Studying Mars's climate helps us understand how the planet has changed over time in other ways. Curiosity has detected fluctuating methane levels in the atmosphere, an intriguing mystery that scientists are still working to understand, as methane can be produced by both geological and biological processes. And then there's the future. If surviving on Mars is difficult for robots, what about humans? If we ever want to send humans to Mars, we need to know if we can survive there. Based on what you already know about Mars, what challenges might humans face if they tried to live there? Pause the video and record your thoughts. Humans would face several major challenges on Mars. Rovers may not need radiation protection or a breathable atmosphere, but humans do. The thin atmosphere provides almost no protection from solar radiation, and temperatures get very cold at night. There's also the problem of obtaining the basic resources we need to survive. Could we extract water from the planet itself? Could we generate oxygen to breathe? These are some of the questions being asked. While newer rovers like Perseverance are testing oxygen generation, Curiosity has helped scientists understand the radiation risks astronauts will face. It has been collecting data on cosmic rays, giving us insight into how we might protect future explorers. Every mission builds on what came before it, helping us understand Mars's past, present, and future. Curiosity has shown us that Mars was once a world with rivers and lakes, a world that might have had the right conditions for life. The challenges of exploring Mars are immense, but so are the possibilities. Every mission brings us closer to answering a big question. Could Mars one day be a world for us?
Hey, hey.